session of the Center for Sustainability Circular Industries talks. Today we are very happy to have with us Paul de Salve. He's a naval architect and project manager at Segula Technologies, and he will be presenting his work on sustainable fuels for the maritime industry. So I'm very happy that you are here, Paul, and without further ado, I would like to give you the floor.
Nice to meet you. So, good morning, everybody. I will be your speaker for today, and as you mentioned, I will be talking about sustainable fuel and more accurately, bio-CNG, so compressed gas that come from biosource for the inland navigation, as we have worked on this subject with a proof of concept. So at first, a brief introduction of my company, just to be very brief. So we are a leading engineering group, French, from a French company, but based in Europe and worldwide. And we are working in most of transportation sectors, mainly in automotive, but also in railroad and of course, with the naval industries, with a bunch of major customers. So first of all, about the CNG. So the CNG is what we call the compressed gas. And what is interesting is that it all comes from waste. So what is interesting is that we can see waste as a renewable source of energy. And so I'm going to talk about a quick cycle about how we can inject the biomethane into the usual network and use it for usual cases and transportation. So at first, you need to collect this waste from multiple subjects. I will talk about it in a few minutes. Then what you do is that you go through the process of what we call methanization, meaning that you need to sort your material, you need to prepare it, and then you will put it in some big containers with a soft top, and you will put some bacteria inside of it, and with into the like a human body, which is going to digest materials, and with the heat and the help of bacteria, all this waste are going to be transformed in biogas, which is going to evaporate and to go on the top of the container. And what would be left, it's what we call digested. So after that, you will need to inject the biogas that has been extracted from the methanization process. And so in France, we have a company called GRDF, which handle more than 90% of the entire network in France. And so they handle more than 95% of methanizer in France, and so they have for each methanizer they have a control station, a control center, and they handle the increase of pressure because methane has to be injected at around 10 bars into the network. And so what they do is that they control this quality, and they put some spell into the gas, which is very important in terms of security, because then you can smell if there is a leak, which is very important. And they also control the pressure to make sure that there is no overpressure or leak of pressure. And the producer will be paid depending on how much volume of metric cube of gas it will inject into the system. And the last part of the cycle is to reuse and to use this gas. And so, as I told you in the second step of this cycle, we will have two products of the methanization. One is biogas, and one is digested. The digested can be used as a natural fertilizer for crops. It's very important. It keeps its property in terms of organic, but you have the smell, which is the smell is gone, which is very interesting. and it's a very, very powerful fertilizer, which is quite interesting. And the biomethane is then injected into network, and it for most of the time it just merge into the usual network with natural gas that has been extracted from fossil fuels, and so you don't see the difference in terms of use, for example, at your home or in your truck, for example, or buses. Most of the time in town you see buses with running on that, but you can also running into power generation, and there is no difference at all. But to know if your gas you are buying come from a biosource, so the ADF they give some certificate to say, okay, we are selling you about 10%, 20% of biogas. So what is interesting is that this whole process is almost has almost a neutral carbon footprint. So, as I was talking earlier, so all organic wastes, for example, it can be manure, it can be food waste, it can be green wastes from cities that have lands that they want to cut grass, for example, and you can collect everything. And there is also what is interesting that more of it, you will see that in between different crops, you have to put some temporary crops to help um, put some nutrients into the soil. And most of the time, what the agriculture guy do, they just destroy these crops so that the energy goes into the ground. But what's interesting is that instead of destroying, we just mulch it, and we can use it into the methanizer. So it's a few less nutrients for the soil, but it will be put afterwards into the digestate. And so all this thing is collected. So I told you there's a methanization, and so you can see that with this green and blue arrows that there is some steps into this progress in which we are emitted some GHG gases, and there is steps in which we are preventing this emission to act. So as you can see, for each step you need energy to do it. So that's why you are going to emit some GHG emission, but and most of it would be in and as a use of fuel, obviously during combustion. But as you can see, because all this organic matter will not emit methane in the air, that's as much emissions that are prevented. So in total, we can say that for this whole process, so you have the amount of GHG that has been emitting. So what is interesting is that if you put into a perspective regarding a bus, that's almost 8 times less GHG emission than diesel. So that's why you have to take into account when you are comparing multiple energy, the global process from what we call from the well to the, so in our case of a boat, to the propeller, or it would in the case of a truck or a bus until the the tire, I would say. So because most of the time you will see a comparison from the tank of the system to the well. So obviously you don't compare the whole process of the production, transportation, storage, reuse of the fuel. So that's why it's really interesting to see the big picture. And in terms of big picture, the bio-CNG is almost at the top of the list. That's why it's a very interesting sustainable fuel for short term. So now let's talk about how to use it in let's say in our product, or in our, or mostly in boats. So what we have developed and what we think should be mostly used is an electrical hybrid system, where you handle all the propulsion generation with electrical engine, and you can change your energy vector. Either it's BioCNG, like in our case, so it's you can maybe it's put in HVO, renewable oil, vegetable oil, or you can use H2, or you can use methanol anyway. So that's really interesting because you don't change electrical system, and the hybrid. So we are talking mostly in serial hybrid system, not in parallel system, which is a little bit different. But in serial hybrid, you have a huge amounts of advantage that are really interesting, and especially in the case of the naval industries and obviously in the inland industry. So what is interesting that you, for example, you can choose the amount of generators that are using energy vector. So if, for example, because such market are quite new, if the engine are not available today, then you can use smaller engine and put more of it. There is no deal of it, and you can also spread the loads in your boats and not just put it in the same place, and so you can better rearrange your boats. Um, you can also use the battery to better handle the change of loads, which is very interesting. So you can see it in the buses. That's for the start of the truck, for the waiting moments. When for example, also in your cars, when you need to have a full peak of powers, and then the battery will take over the power, which is very interesting. Instead of just telling the generator to run a maximum capacity, which we know is not really the best for an internal combustion engine. Also, then you can have with this electrical system possibility to run on full electrical. So it's very interesting. For example, when you are at locks, which is quite often in the inland navigation, then it's interesting for the locksman to not having any noise, any smoke. So it's very interesting. And also when you are running in cities, for example, in France, we got something what we call ZFE, which is a restricted area for emission, and it may apply to inland navigation. So you could run into small channels and being silent. And also by being silent, then you improve the comfort of the crew. As we know, we have more and more difficulties of hiring crews because yeah, the comfort of boats has not improved as much as the comfort in cars, trucks, and everything. So by being silent, by being more um, flexible in terms of also of loads, and it's improves the comfort. And what it's also interesting that, as you can see, we have one system that generates energy, and it's an electrical system that use it to propel the boat. But you see that we can also use this energy to propel to other systems. But because, for example, in boats, we have what we call the hotel load. We have to put energy into some auxiliaries, into the navigation computer, and to a lot of things. And most of the time, in a diesel and a classic way, you have to use additional generators, which it's in term weight, money, and use of fuel. So as you can see, you can share the load, which is very interesting. And in terms of biogas as the main vector energy, so you can share all the system with the railroad and the road sector because, for example, for trucks, they are most of the time the engine used in trucks may be used in boats, which is very interesting. Um, and what is also very interesting is that there is no transformation at all from the moment this energy has been produced until the way it has been consumed by the engine. The only transformation is a compression from 0 to 300 bars. The only transformation. There is no liquefaction. There is no transformation into a solid or something like that, which use a lot of energy, obviously. And also because it's gas uses it every day into your homes, and so you are used to it with the smell, and also due to the very a small limit of explosivity of methane. It's a quite safe system in comparison of liquid gas or hydrogen, which are stored in a very cold temperature. So you have a lot of security issues, and also when we talk of ammonia, it's very toxic. So as you can see, um, it has a lot of advantages, and you can see also the graph that shows the amount of reduction of emission. So as I would say, from well to the propeller, not the tanks to propeller life cycle, which is very interesting for short-term emission. So now let's talk about an actual project to show you how it can be done to um, use this kind of system into inland navigation. So as you can see on the screen, it's an inland cargo vessel dedicated to the sail in France, and but also Belgium, Netherlands, and all pretty much all channel in Europe. It's for some of you that may be aware of, it's what we call the Campinois size. Um, and it's an old boat, which is most of the inland fleet is old. So this refit solution is also very interesting because we are reusing actual boats and just giving them new youth. So it's very interesting. So this boat is about it was built into the 70s. So it's very old, and it has now 3 engines, one main, one for the bow thruster, and one as emergency. So that, as you can see, there is a lot of engine. So into this product, we've developed a new concept. So at first, you will have uh, the gas generator that will produce the energy that can be then used into the main propulsion engine and the bow thruster engine. As you can see also that we are then you will have to rearrange the boats to make another ones for the storage system, which in this case it's a compressed gas with a 6 meter container, 6 meter wide container. So as you can see, a dedicated room, for example, in this case, has been constructed for batteries, and also a new system has been made for the electrical engine. So in this case, how it's happened that all the storage of the CNG, so it is done at the forward part of the vessel. This is where we have space, but this is also where we can say, okay, all the hazards area, dangerous area are located, because you will have masts that can, in case of emergency, evacuate some gas. And so let's say that all the ATEX area, for some of you that may know of this term, are located in the front, and the gas is transported via pipeline in mid pressure. So it's about 50 bars of pressure to the safe area on the back, where it's all uh, watertight and gas tight until the injector of the engine. So that's why you need some maintenance to do it, and you have also a new dedicated CNG room to make sure that you make different location for different use. Um, so also what is interesting is that in terms of improvement of boat, you can also take into account update things to make it more useful for your economy, for example. So in this case, you can make some updates on the boats. So let's talk about more in detail on how it can be done. So on the bow, and on the bow you will have your high pressure storage system. So it's at 250 bars. So that's why, because the public network is about 10 bars, you will need to compress this gas when you are doing the bunkering of the station. You can use different system to store the I would say the gas. So in our case, these are single 6 meter long Type 4 pressure vessel, but you can use also shorter containers. It depends basically on the rules you want to follow. Basically, you will have two type of rules. The one is for railroad transportation, what we call the R100, and the other one is the rule for equipment that are transporting that are pressurized. So we use the second one. That's why we have this long system that can be used at transportation basically on road. And so you have a dedicated high pressure piping that will kind of decrease the pressure and handle also the fact that with this decrease of pressure you may have uh, a decrease of temperature, and so it can freeze the system, so you need to handle this freezing moment. And all this gas is then transferred to the back of the boat to a dedicated CNG room to have something that is segregated from other parts. So as you can see, you have two engine, and so we've made sure that we have two lines that are providing gas to this engine to have redundancy, to have security. And obviously you have your ventilation above it. Then you have your dedicated electrical room, because obviously you don't want to have electrical issues like short circuit or sparkling that are near, or at least in the same location as gas, even if the gas room is what we call the gas safe. So that's why you need to segregate them. And as you can see, an electrical agent is way smaller for the same amount of power than its diesel counterpart, which is very interesting. And so you can reuse this. So this is a model of electrical engine. And so again, you can reuse this space. But as you can see in between these two elements that we have put, so the gas system, the electrical system, you have one main component that is major. It's the batteries. So that's why you will have a dedicated battery compartment. So most of the time you will see lithium batteries. We are talking of a battery way around, for example, what you could have into a Tesla Model S, for example, the biggest, the bigger one with the longest autonomy. So about 100 kilowatt hours. And so a huge amount of work has to be done in terms of security, because as you can see with as you can know with sorry, for lithium batteries you have explosive situations, so that's what you need to handle. Security in terms of cooling, in terms of water dumping, and you can also adjust the chemistry depending on your application. But in this case, it's technology with iron and phosphate or it can be also nickel and manganese. But most of the times, the technology with iron and phosphate is plebiscited in terms of use in terms of security. So there is a bunch of other space, which have not been changed. It's about accommodation, wheelhouse. We have a little bit rearranged the both thruster room access to reaccommodate for the fact that instead of a forward accommodation, we have a forward storage system, and we have developed a universal pushing equipment because these boats, they were designed into the 70s, and they were designed not to push any barge. And so you will see that you will find as many connecting system as there is boats in France. But these systems are very unique to the barge that the owner have. So if you want to, for example, use multiple barge, what we call the Europa barge, for example, then you will need a universal pushing equipment. So that's what we have called put in front of these boats. So I will conclude this talk by a few projection into the business, because as you can see, so we have talked about the powerful progress that we can make with this sustainable fuel and how we can implement this into inland waterways. So this refitting of boats is a major actor into the modernization of the fleets, because most of the fleet is more than 40 to 50 years old, where cars have evolved a lot from this part. But so we really need to modernize it, and this I would say modernization is part of a more bigger picture to redynamize the inland transportation, so to participate into the greening of river transports, because for the same amount of weight that you transfer, the inland navigation is way more clean than the railroad transportation. So yes, obviously you will have to rethink about the time, about the logistic, but if you use greener boats, which are greener than trucks, even if they are old, then you will have really a logistic that becomes a lot more green than today. And so this will also participate to develop the what we call multimodal transport, with hub when you will share loads. For example, you will unload your boat into bikes, or you will unload your train into boats. And for example, you can use a boat that's run on biogas to transport digested through the water, and to put it to rural areas when this will be spread into crops, for example. And so the same, and after that, you can transport the manure and everything to re-put it into the methanizer. And with the improvement of all inland infrastructures, this what we'll think will develop as a new transportation system, and this is how you can close the loop in terms of circular industries. So thank you, everyone, for your attention. And if you have any question, I will be happy to answer it. Thank you.
Thank you, Paul. I'll give you a real hand. There might be some virtual hands, but thanks for this nice introduction into shipping and also how alternative fuels can be used in shipping. Maybe I can kick it off with one first question. I've been looking into inland shipping myself as well with a student at a certain moment, and that project was aimed at using hydrogen as a fuel for the same types of barges that you were talking about. Can you say something about what you think are the advantages or disadvantages of these two systems compared to each other?
So to answer this, you have to look. You have to decide which picture you want to look. Do you want to look at the picture in terms of technical advantage or in terms of emission? And if it's in terms of emission, do you want to look at the picture from the tank to the propeller, or from the well to the propeller? So obviously, if you have a look into emission, then I would say that hydrogen is not a short-term solution, because you need energy to transform it from from the water, and you need also water that is not with salt. But obviously, in terms of combustion, it's very interesting because you will not emit any green gas houses. So it's really interesting when you see from tank to the propeller. From a technical point of view, the problem you can see with hydrogen is that you have the density, the energy density of hydrogen is way less than methane, for example. So you will need more space to store the same amount of energy. And what's also it's very interesting that what we call the explosivity domains of hydrogen is quite long. I think it's from 10% to 80%. So what this domain is that it's the amount of gas into the air which allow an explosion to occur. And as you see, with a large domain of explosivity compared to a small domain, that you will the occurrence of explosion are way increased. So I would say that it's quite difficult. also some things that's maybe difficult is that um, for today you have only few cells that are, I would say, mature enough to transform hydrogen into electricity. We see the appearance of internal combustion engines that are running on hydrogen, but it's, I would say, it's into the prototype phase for now, and most of it are using dual fuel system. They are not using for now monofuel. I have seen some engine running on monofuel, but it's really prototype. So then you are quite restricted in terms of products you can use, and also the what you have to take in mind, it's a bunkering of hydrogen, because then you will have to have a near location to produce and to give you hydrogen into your airballs. So most of the time you will see that you will what we call a swap of containers, when you just bring a container that is full of hydrogen on the harbor, and you with a crane you just swap it, which is quite extensive logistic, but it's maybe more easy than just bring a truck with full of hydrogen and just share it with pressure differential, or with a compressor.
Yeah, thanks. Indeed, I can see all the. It indeed depends a bit on how you look at it and what kind of technology you're specifically looking at. But I understand your well, let's say the disadvantages of hydrogen as well. So thanks for that explanation. One thing I was thinking with the biogas. Then of course what you would need is a source of, let's say, biotic materials from which you can extract the gas, right? Now I know there's a lot of demand for this type of gas nowadays because it's seen as an alternative also in the Netherlands. I can see it at least that it's also used by companies that kind of supply households with green electricity and green natural gas, is that they are using these types of biogas type of systems to make sure they generate just as much biogas as that you actually as a consumer consume. There's a lot of demand for this material, and I can also imagine there are other demands for this kind of carbon neutral fuel. So did you do any calculations on the possibilities of scaling it up to the level of, let's say, that you would want to have every inland waterway boat using this type of fuel? Would there be enough material available to actually produce this biogas?
That's a very good question that you could ask to any sustainable fuel, actually. And so I will try to answer with some other, I would say, arguments. That we think that it's not only one fuel that will solve the problem, but a mix of energy. So obviously, you will have to have a look on to your local environment to see if it's available. To say, okay, can we spread this item to multiple projects? But to come back to your question, I think it's hard to tell, but you can also tell it for electricity, for hydrogen, for methanol and ammonia. But what is very interesting is that we have a lot of crops, and and you will always need to eat. That's for sure. You will always have lands. You will always have um, green waste from city lands, and to implement a methanizer, it's quite easy. The process is well known. It's not that expensive. You may have a lot of funding into from public funding. So I would say that the process of creating this local energy is quite mature. So you can see that the spreading at a bigger scale can be is already in starting, actually. When we talk, so I'm not representing GDF, but we are close partners. So when we talk together, they say that they have more methanizer projects in their pipeline, that there is actual methanizer on work. So as you can see, the expansion is quite intense, and also because the transformation of this product is quite in existence, then you can already use the actual network. So I would say that that's why we think this fuel, if it's not the miracle, it's a short-term solution available to help us go into this more renewable transportation system.
Yeah, and maybe connected to that. So what you can, of course, what you are once you start, let's say, switching to natural gas, you're basically switching to methane.
Mhm.
And methane is, of course, also known as a very potent greenhouse gas. So any leakage from the system will quickly add up in terms of greenhouse gas impacts. So did you do any calculations on that? What kind of losses can be expected and how that compares to, let's say, the gain that you have in reducing the amount of
Mm.
CO2 emissions?
So yes, that's also a very good point. We have to, it's a term that we use. It's a methane slip, and so to answer it, you have to go back to the engine because methane slip has been discovered into the exhaust pipe of bigger containers that are using LNG. Because there is some unburned methane, and this is the leaks because the methane by itself, it's a quite big molecule. So it's easy to make watertight systems that prevent any leaks by itself on the methane. And to evacuate methane in terms of overpressure, it's really an emergency system. It's not usual system, for example, instead of LNG, when you have what we call the boil off, because when you just let a container just sit down, then it will heat up and you will have some boil off. So we need to evaporate the gas. But if I go back to CNG, so it's quite watertight. So in a usual situation, you can keep your gas into your container with a long term. They have made a lot of calculation and they're very strong. Regarding to the engine, you have two type of engine. So the first type is a dual fuel engine, as the second type a mono fuel engine. And what is interesting that I went to factories on engine and I have discussed with all these engine manufacturer, and as it appears they have a different way of using methane as fuel. And I would honestly use the term of, when we had the improvement of using electrical injection instead of carburetor in cars, I would say that you could use the same comparison nowadays because actual in dual fuel, the methane is injected in the air admission system. So then it's not injecting into injector, where with monofuel, we are working, and I will not, it's quite confidential, but so I will not give too much detail, but you have specific injectors that inject methane directly into the combustion chambers. As you can see, with this new type of monofuel electronic injection system, you can better control for each cylinder the methane that is injected, and so you can better control your combustion, and you will reduce by an amount that cannot be told because it's not measured now, but you can reduce a lot of this methane slip. That's for sure. And for now, we don't have any, I would say, particle filter in the exhaust, but because the emission of are already very low, and I have discussed with manufacturer of monofuel engine, what they can say is that in terms of regulation, monofuel engine is already a step ahead of the rules that will be set in 2050. So it's very far away because actually monofuel is quite interesting. But the problem is that monofuel engine are on low power, I would say, from 50 kilowatt to 500 kilowatts. So you can't really spread it to bigger vessel which use dual fuel. So that's why the technology still need to improve to make sure that the combustion of methane is better handled. But yeah, this is also very strong matches. But for example, if I take the case of hydrogen, hydrogen is the smallest molecule you can find on the periodic table, and so if it's the smallest, it's also the most difficult to make it watertight or to make it tight into your pipes, and so you will have leaks everywhere. Into the welds, into the flange, and everything. So, and as it appears, hydrogen so H2 by itself is also very powerful greenhouse gases in long-term emission as methane. So there is good in every solution, there is bad in every solution, but we have found that the compromise of methane, it's on the level, it's quite interesting, and it's available today. So that's why we focus on this system. But what is you see is interesting that with an hybrid solution, for example, if tomorrow methanol is okay, or ammonia is okay, because we know that ammonia does not produce any greenhouse gases at the combustion, only at the production. And if we handle the toxicity, if we handle the production, then you can just change the main vector energy and you can use your hybrid system. The same for hydrogen. If, for example, tomorrow we know that they are developing some solid state storage system in salt, for example, then if this system are very efficient and everything, then you can just change your main energy vector and adapt it. So this is why I think that an hybrid system is very powerful to make sure that we can serial the whole refit of boats.
Thank you. Thank you, Paul. I don't see any other questions from the audience at the moment. So I think with that, I would like to thank you very much, Paul, for your introduction into your work here.
You're much welcome.
And for the others, see you around during the next meeting. Thank you.
You're much welcome. And if there is some questions, some FAQ, question, I would be happy to answer it.
Yeah. Okay.
Have a good day. It was nice talking to you.